Welcome. In this series, Dr. Jonas will code his own HTML language in C. But all of these techniques will also be applicable to any program language you create or any existing language you want to parse. He will program a Lexer which will transform the code into tokens. The HTML parser will then use these tokens to interpret the language according to the grammar we have defined. Then you can use the HTML for anything you'd like: rendering web pages, formatting console user interfaces, or writing your own React.js. Let's get started.
Sup guys, welcome to today's show. So today we're gonna start a new project where I'm gonna develop my own HTML. And the purpose of this project moving forward is to create my own HTML, my own CSS, and use that to create console-based graphical user interfaces for C applications. But there's a long way there, and today we're going to focus on parsing the HTML. And we're going to code this in C. I will inform you about what we're going to do when we're going to do it. So I'm going to use bash.bs to create a template. And if you don't have bash.bs, download it from the repo. It's repo.drbirch.com. And maybe I should increase the font size just a hair. So let's see. Let's do 14 bold. And set this to full screen. All right. So I have a whole episode about bash.bs. Search for build system. So I will call this project Hyperbird. And hyper is from the hypertext markup language, HTML. And it's the default C template. And I'll go into the Hyperbird directory and, as usual, set it to my home. And we have makefile and simple.c and .h. I will go into Sociopath and find my directory. Let's see. Where am I? Hyperbird. Ah, there it is. So I will launch this in VS Code, where we will be doing our development today. So let's see. Let me just make a few adjustments. Let's see if the makefile's okay. I want to change the standard to C23. And you need the latest GCC version 14 something to be able to use C23. Otherwise you use C2X, which is the default. Right, that's good. I'm also gonna change these macros. So our int 8 is 1, this is 2, this is 4, and this is 8 for the number of bytes that these data types represent. And yeah, that's okay for this. All right, so how to do this? I'm gonna code this thing a little bit influenced by the functional paradigm. Not entirely, not book correct, but some influences. And I'm going to start by defining a data type for strings. So let's create a struct s string, and the string in this representation is, let's see, I want to have a length. So let's say we have an int16 length, and we'll have a pointer which points to the current position. And then the actual data. So let's make this. Let's do this. int8 data, and we don't define a number of bytes. So we will allocate using malloc. And then I want to do a type definition. So let's do struct s string, and this will be a string with capital S. Okay, so this is how we'll handle strings, and this will be which is called an immutable variable or data type. Which means that once it's created, it cannot be changed. So every time we need to update this, we will destroy this and create a new one. And why do we want to make it like this? It's for security reasons, basically. When we use immutable variables, it's much safer. Alright, so now we have a string. What else do we do? Well, let's see. We need to have tokens. So basically, let me show you what I have in mind. I want to create a simple HTML-like language, which looks, let's say we have body, and we have bold, and then we have some text, and then an ending tag for body. So what we need to do is we need to put this through a Lexer. And if you watched my episode about creating a compiler, the first step is coding the Lexer, which transform this into tokens. So we will have, in this case, we will have if we make a simple table, we have token, let's see, value. So this first body tag will be tag start. Let's do one more here. Body, and then we have tag start bold, and then we have a text token with the value text, and then we have tag end bold and tag end body. No, not up there. There. So that is our first mission, to be able to parse this with our Lexer, turn it into these tokens. And all of these are different data types. And these are their values. All right. So let's define our tokens. Maybe we should even put that in our own, in an own file. Let's see, because it's probably gonna be quite many in the end. Let's do that. Let's do a new file and let's call this tokens.h. And we will include this in our Hyperbird. And if you don't have birch utils, by the way, you can also find that in the repo. So we'll include our local tokens.h. And let's start by defining what a start token is. So we'll do a struct s tag start. And this will have a tag type. So that will define what kind of tag it is. And it will have a value which will be, should we use our string data type for this? No, I don't think so. We are going to use that, but I want that for a different purpose. So let's just do this value. And later on, we will also have attributes here. So if you know your way around HTML, some tags have additional metadata to them. So for example, you can do font color equals red. So font is the HTML tag, and color is the attribute, and red is that attribute's value. So let's put it in a comment for now. We will have something like attributes, something like this. But that will be later add-ons if needed. For now, this will be it. We will type def struct s tag start. Right, we need to it's complaining about int 8 because we have all the definitions inside of this file. Maybe we should go the other way around, but we can't really do that, can we? this is not very nice, but I think we will have to do this for now. I will figure out a better solution later on. And we need to define what a tag is. And that will be an enum. So let's do enum e tag. And here we'll list our different HTML tags. For now, I will only add a few. So let's say, for instance, that we have HTML, which is number 1, and we have body, we have, let's use this bold thing. And let's start there. I will type def enum e tag as tag, like so, and the error has gone away. So basically the tag start is gonna contain HTML, for example, and the value in this case will be HTML. Like this, as a string. So we have something to compare to when we need to parse it. So that's start tag. We also need a corresponding end tag. So struct as tag end. And this will be the same tag with a type int8 value. Type def struct s tag end, tag end. And then we have a third category. Let's add one of these here. Let's say BR, for example. BR is a break. It creates a new line inside of the page. And BR does not have an end tag. So it's basically its own end tag. And when you code a variant of HTML, which is called XHTML, you usually do like this to indicate that this is both open and close for this tag. And this is the style that we're going to adopt. So let's create a third category for self-closing tags. So struct s self-close. And this will also be tag with a type, int8 with a value. And we want to type def struct s self-close to self-close. Okay, so now we have defined the different tags. Let's create a token as well. So the token can be any of these. So let's see. First we need to define an enum for the token type. So enum e token type, and we're gonna have only a few. It'll be 4 for now. So we will have a text token. We will have a tag open, tag close, or do we really need to define this? No, we probably don't. Let's just do tag like this, and then we can define it inside of the type like we have done here. So type def enum e token type, and this will be token type, like so. And now we can define our actual tokens, and this will be struct s token and the token will have a, let's see, a token type. And then we will either have a text or a tag. I think I will do this, by the way. It will make other stuff easier if we do tag open. It'll be a little bit of duplicate code, but it will help us in other ways. Tag close, self close. Let's do the same here. Self closed, self closed, and self closed. All right. So now we have the token type. Now I want to do something like, so in the later C standards, we should be able to just do union like this. And then we define different things. So we will have a, let's say, tag end, and tag, let's start with tag start, by the way. Tag start. Let's keep the same names, by the way. Tag start, tag end. Self-closed is okay. Self-closed, tag end, tag start, yeah. So we have tag start, we have tag end, and self-close. We can't call this self-closed because we are already using it up here. So it will collide. That's why I did start and end. But what can we say here? Self. And we also need one for the text. Which we haven't defined yet. But it will be text. Text. No, we can't use text. text token. I don't like this name standard, but it'll be alright. Alright, so a union basically means it's like a structure, but we will not have all of these at the same time. We will be able to use one of these, so either this, or this, or this, etc. And since a token is only one thing, it makes sense. And what should we call this thing? Well, this is the actual token, the contents maybe. And that's all for this. So we'll do type def struct as token. And let's also create an own data type for tokens plural. And this will also be an immutable structure. So we'll do struct as tokens with an S. And this will have a token I don't think we have used tokens with small letters, have we? And we also need to know how many they are. No, wait a second. Let's start with that. We need to know the size of this thing. So let's do an int16 length. And well, we're gonna have token. Let's do T's. So T for token and T's for plural. Right. And type def struct as tokens and tokens with an S. Okay. We only have one more data type to define at this point, and that is this text token thing. So what will that be? Let's make it a string for now. Type def string text, like so. Okay, we haven't defined that in here. It's annoying with all this duplicate code. I will figure something out, I promise. But I don't want to dive into it too much at this point. Okay. Why do we have an error there? Okay. It doesn't allow for this. It does with strings, but apparently not with our tokens. So So let's make this a pointer instead. All right. So how do we create any of these structures? We need to create a couple of constructor functions. So let's start by creating this string structure. Let's do constructor functions. And we'll use this syntax. We'll call them make and then whatever it is. So make string, for example. And this will return the string. And I think I'm going to use pointers. So make string. And do we want to put something inside of here? Yeah, we kind of need to. So let's do int 8. Like so. And I also want to do, let's wait with that, by the way. Okay, let's create this function. So it'll be a string, make string. It'll take a int 8 pointer input. We need to have a pointer. And let's do some sanity checking. Let's assert that we have an str. And that the length of this, so maybe we should create a function that checks the length. Well, we can use the standard C library, but it's kind of good to have our own as well. Let's call it string len. And let's make it instantly. So int 8, no, it will return int 16. String len, and it will take an int 8 str. We need to assert that we have an str. And we need to have some kind of counter. And we need to have a pointer. Which we'll call p. And then we'll do a for loop where we set p equal to str. We set n equal to 0. We're going to loop as long as we have a p. And at each iteration, we're going to increase p. We're going to increase n. And that's all we need to do. And then we return we return n. Now we have a string length function of our own. So let's do int 16 stringlen int 8 star. And we can go back to our make string. So what do we need to do here? We need to allocate for this string to begin with. And how does this thing look? We're gonna have length and the current position, and the rest is the data. So we need to first calculate how many bytes we need. So let's do an int size, and the size will be equal to the size of a struct s string. So that basically corresponds to this part, and then we need to take into account the number of bytes in the string. So maybe we need to do, well, let's do this. We do create an n, and we set n equal to, no, we can't do that. We must first assert that we have a string, right? So let's remove this. And let's assert that we have a string. Then we will set n equal to the string len of str. And now we can assert that we have an n. And when we have an n, we can plus that to our size, and we have the size of the structure. So now we can set p equal to the int 8 of malloc size, and we assert that we have a p. Okay, so now we have an empty structure. Let's also zero it out just to be sure. So we'll give the int 8 version of the p and the size. And now we'll take the length, and we'll set it to n. We'll take, let's wait with the cur. For now, we will copy into this int 8 thing. So we'll have a copy function. String copy, and we want to copy into p data, and we want to copy from the string n bytes. And then we can set the current position equal to p data. And we'll return p, like so. And there is our constructor function, but we need to create this copy, this string copy thing as well. So let's see, shall it return anything? No. We will have a void string copy, which will take an int 8 destination, an int 8 source, and an int 16 size. And this function will be very similar to the one that we wrote above. We're going to have an int 16n and an int 8p. We need to assert that we have a source and a destination and a size. And then we can set p equal to, we don't just need a p, we need a p for the destination and a p for source. So let's call this DNS instead. So we'll set D equal to destination and S equal to source, and N equal to size. And we're going to continue as long as we have an N. At each iteration, we will increase the D, and we will increase the source, and we will minus the N. And what are we going to do inside of this loop's body? Well, we're going to take the current position of D and set it equal to the current position of S. And then we'll return. Easy peasy. So we will have a void string copy, and we'll take an int 8 star, an int 8 star, and int 16. Like so. What's next? Well, I want to have one more string-like function, but it should be dealing with our own string data type now, not the regular string. And I want to have a function which is called get, which chops off 1 byte from this string. So the first byte, and it returns a new string. No, let's see. Yeah, it needs to return a tuple with the byte that we chopped off, and the new string, which means we need to define a tuple data type as well. So let's say struct as tuple it contains a string, and it contains an int 8, which is a char. So type def struct as tuple. And our get function will return pointer to a tuple, or maybe it will just return the tuple. It'll call get, and we're going to supply this thing with a string. Yeah, with just a string. And I want to create a destroy function as well for this string. So let's say s destroy. So the s will be the string data type that we defined. Since we're gonna use immutable data types, we need to have destroy functions for them so we can clean up the memory when we alter stuff. And that will be a quite simple thing. We will just do void s destroy, and it takes a string s. Did I make it a pointer? I did not. This should also be a pointer. And let's see, it contains length current data. Yeah, we can just, we don't even need a function actually. We can just create a macro in this case. So let's go here and we define s destroy. We have an s, and we'll just do free s. And I still want an own function for it because we're going to have a couple of these destroy functions, and not all of them will just call this free function. So we can remove this. Okay, let's create this get function. So it will return a tuple, it will be called get, and we'll have a string s. We'll assert that we actually have an s, and we need a tuple for the return value. Well, let's wait by defining that. Let's define the contents separately for now. So we will have a string new, and we will have an int 8c. So we need to assert that we have an s. How do we deal with failures? Well, we can just return a tuple with all zeros. So if the s length is 0. Then we will define a tuple with the return value, all zeros, and we'll return that. Okay. Otherwise, we should be able to get something from this one. C is going to be equal to the current byte in the string, and our new will be equal to a copy of that first thing. So let's say this is an S copy, and we'll give it the S. And if we can't do this, let's do this instead. Let's use the very hated goto. So goto fail. And we'll do the same here, goto fail. And at the bottom we'll define fail, and here we want to do tuple ret is equal to all zeros and return ret. Maybe we should call this error instead. If we do get a new copy of this string, we want to make sure that the new copy has moved the current position one step. So it will basically contain the same stuff, but it will nevertheless be one less character, which means we also need to decrease the length. And then we want to create our successful return value. And what we have an S and a C. The S will be equal to our new, and the C will be equal to our C. And we want to destroy the old one and return ret. Okay. So we have written quite a lot of code without testing it. So let's see if it works. Let's create a string S1 and S. Let's just do S for now. And let's have an int 8c. And we'll set S equal to make string. And we'll have something hello world. And then we want to set we need to have a tuple as well. We'll set t equal to get, and we give the s. And if this errors, which means we will not have a c inside of it, we can print error and exit. Otherwise, we want to print c and let's also print the new string that we get back. So new is equal to this. And we'll give our, no, that's not right. And we'll give our C and our TS return 0. All right, let's see if we made any errors. Let me just save all of these files. Okay, a couple of errors, but not too many. Right, we never created the copy function. Let's start there. So let's define our copy function. Let me see how I used it. Copy, copy, copy. Not string copy, that's for indate stars. But we did use, where did we use it? Right here. So it takes a whole structures, a whole string structure, and makes an exact copy of it. Simple enough. So let's define void scopy, and it will take a string, and not void, by the way. It should also return a string. And we have a length and a cur and a data. Well, let's start with the length and the data. That's simple enough. So we'll have a string scopy and a string s. We want to assert that we have an s and that it has a length. And now, what do we want to do? Well, we need to have a pointer. And we need to be able to calculate the size. And the size will be equal to size of struct s string plus length. And we will allocate for this and let's assert that we do have a p as well. Okay, so far so good. Yeah, we can assert that. If we have, the only way it can fail basically is if we have some kind of, we have run out of memory, and in that case something is enough wrong to be able to abort. Okay, now it gets a little bit complicated because, well, if this has never been updated, if we have never run the get function on it, it will be very easy. We just copy the whole stuff. But it's a little bit trickier since, let me show you an example. Let's say we have the string hello world. And this size is equal to 5, 10, 11. So if we want to copy this, we just copy these 11 characters. Let's say cur is pointing towards the H in this case. But now we run the get function twice, for example. So we chop off 1, 2. This will go down to 9. The cur will point to L. But the data will still be hello world, right? Because we don't delete the data. So if we want to make a copy of this, we have the 9 here. Well, no, we can't. Well, yeah, well, maybe we can copy 9 from cur, and that will work, right? Okay, never mind. It was quite simple after all. I was too hung up on the data part of it. So let's see, let's zero out our new thing. And by the way, I just want to double check one thing. Make string. Right, this should not be int 8. This should be string. Alright. So now we need to fill in all the blanks here. Let's start with the length. Pretty easy. The p length will be equal to the s length. And the data will be pretty easy as well. We'll just use our string copy function to copy into p data from s cur, and we'll use s length bytes. Simple enough. But we have one left, and that's the cur. What should we point that to? Well, we can point it to our new data. That's pretty good, actually. The data will not contain any additional overhead. So we'll just do p cur equal to p data. Nice. And now we will do s destroy on the first one, and we will return the new one. Okay. Still have one error. %s expect argument type char, but argument 3 has type string star. Right, we need to go one level deeper and grab the cur. So this should be t.s arrow cur. And what is this? C may be uninitialized. Will it now? Yes, we have not allocated for that. Let's remove this instead and just show. No, let's do it. This should be C is equal to this. And now I believe it will compile, almost. Incompatible types. When assigning to type int 8 from type tuple. Okay. Okay. This should still be T, but the C should be equal to this, right? No, not an arrow. T.C. Okay, it compiled. Do you think it's going to work? I think I do. Oh, double free. That's not nice. How does that happen? We don't have too many of these frees. The only thing is s destroy, which we use here and here. Let's see. We destroy s, and here we destroy s. So we get T. That's weird. make the string, and we get s. So we do all of this stuff, create a new thing. Wait a second. Right. When we do this new thing right here, we destroy the old, right? So let's not destroy it inside of the copy. All right, now it should work. Almost. We do get the H of hello world, but we did not really get the other thing. It only copies the H a lot of times. Interesting. That should be our string copy function, which doesn't work properly. Right, we increase source. We should increase s instead. All right. Now it works. So it chops off the h, and the rest is this. And since you asked me to make the episodes shorter, I think we will stop right here for today. But this will be a new series that we're going to continue, so please like and subscribe if you think it'll be interesting. And you will see when I release the next episode. And thanks for watching. Thanks for today. Sup guys, welcome to today's show. So today we are going to continue our Hyperbird project, which is my HTML language for C. Last time we created a lot of the basic structures and succeeded in creating a string data type that we can successfully chop off the first byte and return it. So pretty simple stuff thus far. I want to refactor a little thing though. This text token that I have, I want it to have the same structure as the other tokens. So let's do something like struct s text token. And we'll give it a tag with the type and an int 8 with the value, like so. And we will type def our struct s text token to text, like this, and remove this part. So now I want to create a show function which will print a token. So let's see, I think I'm going to, before that by the way, I figured out how we can remove this thing, this duplicate code. If we just remove this like so, and we go to Hyperbird and we remove the include of tokens, and let's put it inside of our C file instead. I think that was going to work. Let's see if it compiles still. No. Redefinition of struct as token. Maybe I didn't save this one. Okay, now it works. Good. We should be as dry as possible, right? Don't repeat yourself. Okay, so let's create a signature for this function. Two functions, actually. I want to have a void show token, and it will take a token. And I want to have a void show tokens pluralis, which will take tokens. And I wonder if I should create its own C file as well, but I don't think I'm going to do that. So let's do void show token, or wait a second. Maybe we should not return void. Maybe we should return a string instead. Yeah, I think I'm gonna do this. Because then we can simply print that string, and maybe we'll use that string for other stuff as well. So this will be int8 show token, and it's gonna take a token. And what are we gonna do? Well, we're gonna have a ret, and then we will switch on the token dot type, right? Yes. And if we have a text, I think I just called it that. Let me copy this stuff. Let's take all of this. And we will put it right here inside of a comment for now. Or it will always be a comment until we remove it. And maybe clean it up just a little bit. We don't need all of this stuff. All right. So if we have a type text, what are we going to do? We are going to set ret equal to what exactly? Maybe we should make this a pointer after all. It'll be easier if we just do let's create a TMP with a size of, I don't know, let's say 32. No, maybe we need it bigger. 256 is good. And let's zero out this thing. And I'm gonna keep the ret though. And let's assert that we have a token. We can perhaps do token dot type. So if that is 0, it's an error. Alright, so let's see. Now we can use s and printf. And we can put our TMP size 255, and if it's a text token, we'll just copy that text, and that'll be token dot text token dot value, like so. Maybe we can even do this. And maybe we can do a couple of copies. And what else do we have? We have a tag start. And in this case, we want to print it like this, right? And it's not a text token dot value, it is start value. And we'll do the same by tag end, but this will be a slash as well. And finally we have this self-closed thing, and I want to print this like this. And maybe we'll have some default kind of thing, which will only be well, nothing. We can have the default and maybe even a break, but the string will be empty, right? Let's see if we can tab this out and still make it fit. Yeah, that's kind of cool. And then we'll simply return the ret, right? So that is when we have a single token. What about tokens, pluralis? Let's take this thing. And put it inside of our comments. We can remove the other stuff. So this will be int a show tokens, and we will have a tokens structure. So now we need to go through this list of tokens and concatenate that to our string. Right. So let's see. We need to be careful here so we don't overflow the buffer. We can make it kind of big, let's say 2048. Let me just do a quick calculation. So if we have the maximum to 2048 and the maximum size, oh, not echo, expression, right? Okay, that's only 8 of those. But most of them are very, very small though. By the way, we can't really return this thing. We need to make this a static. We can't return stuff in this function stack. Well, we can make this kind of big actually. Let's add a 0. So in this case we will have 80 of those. I don't think we will go past that. And we need to have an int 16 which makes sure we don't overflow. Let's create one for the total size and one n for each and every one of those. Let's also create the pointer p, and we also need to have a token pointer t, and we need to have a variable which makes sure we don't loop past the length. Let's make that I. Alright, let's see if we can get this to work. We'll have a for loop where we set I equal to the token's length. And let's loop as long as we have an I. And let's just do I++. We can also set our t equal to, maybe we should give this a name though. This is t's, plural. t should be equal to the t's. That's this thing, the list of tokens. And we will decrease I, but we will increase t. Okay, so let's see how we do this. We'll set p equal to show token, and we will give it the current token, which is t. And if we don't have a t, we break. And if we don't have p. And if we don't have any length of this p, we can continue. Otherwise, we will calculate the string length of p, and we will add that to our total. So total plus equals n. We also need to zero initialize this total. And if total is more or equal to size of buff, we break. Otherwise, we'll do a string copy. We need to have something pointing to the current point in the buff. So let's set cur equal to buff. And what are we going to string copy? Well, we're going to copy it to the current position inside of our buffer. And the thing we want to copy is p with the size n. Then we need to increase our current position by the same number of bytes. Let's see so I don't miss anything here. So when we have copied this result, we will increase t, going to the next token, we will decrease I. Yeah, I think it's okay. Let's also zero out the buff in the beginning. And we do need to make this a static buff. So we, at the end, can return our buff. I hope I made this right. How can we test this? We need to create a couple of tokens, right? So we can remove this comment. And let's grab this part again. Because we remember this text, tag start, tag end, self-closed. So let's go inside of our main, clean this up. We will create a comment where we paste this thing. Alright, so let's create a couple of tokens. Let's say token HTML. And I'll cheat and do it this way. This should be equal to, the type is a start tag, tag start. And right, we have this union thing. We can probably just do content. No. Can we do dot content? Dot start. Maybe we should break this up on several lines. And let me just check how start token looks. Right, all of them looks the same. We have a type and a value. Okay. So let's do this again. We have token HTML is equal to a type which is a token start, a content, I wonder if we can do something like this. And inside of here we will have a start. These are several levels. I'm not sure if we can initialize it like this, but let's try. And here we set the type again to token start, and we set the contents to HTML. Let's start here actually with 1. And we'll do a printf. Let's put it inside of quote so we see a little better. And what are we going to print? Well, we're going to print show token HTML. And we'll return 0. Alright, I think we need to edit some stuff inside of where exactly. This is probably okay. But here, token, text token. We probably need to add contents as well, which break this up in 2 lines, unfortunately. And we'll do the same here, contents. And finally, we'll do the same here. Contents. And this does not fit at all. Okay, it's become quite a lot uglier than before, but maybe we shouldn't care too much about that. I want to make it work though. Okay, let's see if we can print this HTML token and if it compiles with this weird structure. So we'll make clean, we jump down a little bit, clear the screen and run make. Oh. Wow. So let's see. Expected parentheses before the dot token. Yeah, okay. 38. It's here. Yeah, we kind of need to name it something. Let's call it T. I thought it looked weird, but I didn't really know why. I wonder if this makes it possible to get everything on a single line. Maybe it does. This works. And this. And this. Well, this will not work. At least I don't think so. No. Annoying. Well. Okay, let's see if this fixes things up. Well, still a couple left. Case pointer targets in passing argument 1, right? We need to convert as well. This should be a char. And we're back at this line break. Maybe we can cheat a little bit. And we need to do the same here. Need to cheat a little bit more. And same here. Same here. All right. Okay, that's better. Error union anonymous has no member named self closed. So it's text token start and then self. Huh. Look, no. Okay. All right. Type equals token start undeclared. token start. It should be tag start. The words are too similar. Tag, token. I will probably make that mistake many times. Tag start, blah blah blah, has no member named contents. Tag start. Right, it should be data, I think. Value. And we can't initialize it like that. Can we do this? Nope. Alright, that's a minor problem though. No, wait a second. This is a flexible thing. That's right. So this inner part we need to malloc. So this start thing, what is it? It's a tag start. So we need to have a tag start pointer which we want to malloc like this, size of tag start, struct s, tag start. We assert that we have a p, we zero out that p, size of struct s tag start, and then we need to string copy into this value HTML, and this needs to be int 8 4. Think this is gonna work, and now we can probably just set start equal to p. I guess, because we have the contents and we have the start. Let's try that. Perhaps we need to make it a pointer. Incompatible tags when initializing enum etag using type tag start. Start is a tag start. Inside the contents, we set start equal to p. It's a weird error message, but perhaps it is because it's not a pointer. So let's make these pointers. Which means we probably need to edit our print token function a little bit. Show token, I mean. Because now this needs to be an arrow. Let's cheat a little bit more. And now I think it'll compile. It did. Let's see if it will print an HTML. If everything works, it should print this, right? Hyperbird. Okay, so far so good. Now we just need to create a couple of those. Which is no easy matter. All this code just to initialize one. That tells me what exactly? That we need to have a constructor function. So let's turn this into a constructor function, which will return a token, make token, and what is the input? Well, we need a token type, don't we? Token type. And we need a value. So token type, and we need to have an int 8 value, like this. Right, so the only thing we need to change is this right here will be the value, and this right here will be the size, which we need to define int 16 size. And size, let's do this after. And size will be equal to the string length of value. At the end, we will simply return p. Let's put this inside of here. Constructor functions, constructors, token star, make token, token type, int 8 star. Like so. Maybe we should, no, we can keep this. And now our main will be easier to create. We can simply do something like token, and we make a couple of those, T1, T2, T3, T4, and T1 will be equal to make token. This will be an tag start and HTML. Our second can be, let's say, body. Then we need to change this as well, tag start, and this will be a text. Hello world. Let's insert a BR, and that is a tag. It's a self-closed. And then we'll have a tag end for the body and a tag end for the HTML. So let's create two more of these variables. We'll have a T5 and a T6. Alright, so how do we put all of these inside of this other thing, the tokens structure? Well, first we need to allocate this. So let's define an int16 size. Let's define a tokens t's. Maybe we can wait with the t's. We do, however, need a t. Yeah, let's do that. So t will be token, and we're gonna malloc the size. And what is the size? It's the size of one token times 6, because we have 6 tokens. Let's assert that we have a t. Let's zero out the t. And let's put some content into it. And this should just be an array, basically. So I guess we can just do t0 equals t1. Like this. And now we can create our t's, which will be tokens, and it'll have a length of 6, and it'll have a what did we call it? Tease. It will have a tease of T in this case. And let's do printf. And this time we're going to do show tokens, plural, and we give it the tease. Alright, this will be interesting. And let's clean up a little bit. Let's see. What do we need to clean up? The make token, what does it return? It returns this. And let's see. Yeah, we need to have a destroy function. 2 actually. We need to have something which destroys a token and something that destroys tokens plural. Maybe we don't need the second one yet. So how do we destroy a token? Destroy token. And we have a token star T. Yeah, we just need to do free on it. So let's create an alias instead. Which will be a macro. Let's call this define destroy token, and we have a T. And this will just do free of T. For now, anyway. So we need to destroy token T1. 2, 3, 4, 5, 6. What else do we malloc? Well, we do malloc the array inside of the tokens structure. So let's just do free tease dot tease for now. Alright, let's see if we got this right. Oh, what's that? Conflicting types for free. Have void star. Oh, maybe I didn't delete the. Did you know that I made a book about computer networking? You will learn how the internet works and how everything works under the hood. It's a complete beginner's course, but it has some advanced elements as well. And you will learn network design and network security and all different kinds of stuff. For more info, check out books.drbirch.com. That is books.drbirch.com. Thank you for your support. All right, welcome back, you guys. Let's continue with our troubleshooting. Came to think about something though. This isn't really nice. So I'm going to code a function, or rather a macro, which will destroy a list of tokens. So let's see. Let's go into this. And we already have a destroy token macro. This will be a destroy tokens macro. And it will take a tease. And what are we going to do? Well, we're going to do something. Let's start by defining a variable. Let's do int 16 n. And then we'll do a for loop where we set our n equal to the t's length. And we're going to loop as long as we have an n, and we'll do n minus minus. And let me don't forget those backslashes. All right, so what are we going to do inside of this loop? We're going to call destroy token, and we're going to give the t's and the n as an index. And when we're done with that, we will also free the entire thing. So that'll be t's t's. Let's put this inside of parentheses. It's a good standard to always put the argument to a macro inside of parentheses, because you might want to send like an expression as an argument, and that won't work in all cases unless you do like this. And let's also don't forget the semicolon. And when this is done, we need to end the loop, and we'll end it by saying while false. So we will not loop. We will only use this as kind of a lexical scope. Kind of thing. Right? So now that we have this thing, we don't need to do all of this ugly code. All we need to do is call destroy tokens and give the t's. Like so. Alright, so let's see what else was problematic. We had a lot of errors relating to returning tag start star from a function with incompatible return type token star. 191. It's this thing. So we return a P, which is a tag start. Why did we make this a tag start? That's weird. Make token. Let's see. A token is this thing. So it can be tag start, but also these other stuff. I guess we should return HTML in this case, but this will only create a tag start token. How can we make this more general? I guess we can't. We have to make different functions, I suppose, because almost everything is different. So let's rename this to make tag start. It will still return a token though. And then we don't really need this token type kind of thing. And where did we use that type? Did we even use it? No. Alright, it will not be very good looking since we have to copy paste some code. But let's just make it work for now, and then we can refactor and make this look better. So we have a tag start. Let's make a tag end. So we'll need to change this P to tag end, and same here. What else? This needs to change. Tag end, and start needs to be end, and this need to be tag end. I think that's it. So let's make a self-closed as well then. And we need to change this, self-closed. And we need one for the text token as well then. Let me just double check that I picked the right variable names for these. So we have text and text token. Text. And where is the, here, text token. So this should be text token as well. And now we can create our make token. And it will have the same signature as before. So token, make token, token type. Type and what's the other one? Indate value. So we will switch on the type, and if we have a text, we will return make text value. If we have a tag start, we'll return make tag start. And then we have tag end. And finally, if we have self-closed, we'll return make self-closed value. And default, I don't know, we error out. Alright, like so. Let's also create a couple of constructors. The token make something, and we give an indate star. And we'll have make text and make tag start, make self closed, and finally make tag end. Alright, and we still call this make token. Do we pass the right arguments? Seems like. Alright, let's see what it says. Initializer element is not constant. Okay, so the initializer needs to be constant. That's very annoying. So we need to do HTML dot contents dot start equals p, and remove this middle part. Right. Same here. And HTML contents end is p. And finally the same with the text. HTML contents text token is p. Okay, let's see if that works better. Incompatible types when returning type token instead of token star. We should be able to fix that with a cast, I think. It's a little bit annoying when you have 4 functions and you need to change stuff in all of them. Well. Let's see if this works better. Cannot convert to a pointer type. Oh. Well, I suppose we just have to create a pointer then. token ret, and ret is equal to HTML. We probably need to make this, no, and we'll return ret. And finally the same with our text. Shouldn't have the name HTML either, because this can be any of the different types. Never mind. Incompatible types when assigning type token star from type token. Isn't the whole point of a pointer that you should be able to point it towards a variable of the same type? Okay, let's take the address instead then. Is it just me, or has GCC become dumber of late? I'm pretty sure it could deal with this stuff on its own before. Alright, that's better. Assignment to tag start star from incompatible type self closed. 225. Forgot to change the type. Self closed. Did I with the other ones? This is tag end, tag start. What about text? Yeah, that too. Little by little, it's starting to take form. What now? Didn't I save? 225. All right. Conflicting types from main. Yeah, that's easy enough to fix. Pointer targets in passing. Argument 2 of make token differ in signedness. Okay. Let's see. Let's start with main. This should just be a void for now. And then we have a little bit of trouble with these. So let's convert them. We need to have them as int8 and not char. And now I think most of the errors will disappear. Yes. Incompatible types when assigned its type token from type token star. Okay, same thing. from type token double star. Maybe we need to go the other direction then. All right, that's more like it. I is undeclared. This is inside of our macro. Typo. Anything else? Expected blah 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 before 4. It's the same thing. Maybe it compiles now. Almost. Incompatible type for argument 1 of free. What do we have? We have tease dot tease and then n. Definition of macro in expansion. Tease dot tease and then one of them. Do we need to do reference? No. Invalid type of unary star, have token, struct as token. What about this? Alright, it's compiled. But will it work? Hyperbird. Corrupted top size. Corrupted top size. I have never seen that before. And malloc is failing. Weird. So which is the first malloc we do? It's probably instead of make token. So we go to the make token, and this is the tag start. So we go here, make tag start, value. And p is equal to tag start malloc size of struct tag start. Let me just put an exit here to see if this is actually the one that causes this. Yeah, it is. No, it's not, I mean. So which one is it? How many mallocs do we have? Yes, copy we have already tried, I think. Make string, same there. Make tag start. Size of token times 6. Let's see. Size of token. And what should this tease contain? Well, it's an array of tokens. But shouldn't it be an array of pointers to tokens? I think that makes more sense. So let's make this token star instead. And let's change this to this. And we probably need to change a few dots to arrows as well. Let's search for T's. Show tokens. T equals T's. Let's see what it says when I try to compile it now. Maybe this is not the right way after all. I don't want to change too much about these tokens because we already was able to print. No, maybe we haven't been. Let's see if it's this malloc that fails. see what it says. No, it's not that one. Let's do something like this then. One. Let's also flush the buffer. Two, three, 4, 5, 6, and 7. Let's see how many numbers we get. Interesting. We get the 4, and then it fails. Which means that if we put an exit 0 here, we should still crash, right? Yes. But if we put this here, we shouldn't crash. Okay. At least we got some intel. But now I forgot which one it was. We got the 4 and then we crashed. So it's a self-closed. What's different about the self-closed? I think I made all of them pretty much the same, didn't I? Tag type int8 value. What happens if I remove this assert? Okay, so it's not the assert that prints the error. It's actually malloc itself. This is really weird. Is it something to do with the size? Okay, it's not that one. So it's not the self-closed. Is it this maybe? Okay, so it's a text token. So P is equal to text malloc size of struct s text token. And if we comment out this thing, then the assertion fails. Okay, so let's do the same here then. Print the size. Because that is the only argument to malloc. What else can it be, right? Size of struct s text token. Four bytes. The tag is probably 4 bytes. What about the value? What do we do with the value? We allocate one of those. I forgot to take that into account. But how does malloc know that? Weird stuff. But let's first calculate the size. Let's create an M size for malloc size. And we'll set M size equal to size of struct s text token plus the other size. And we'll give the M size to malloc and to our 0. Okay, so this is how the code was supposed to look like. But why does only this trigger whatever this is? Well, so we'll have a, oh, I forgot, I need both. And so size och M size do this. Size is size of struct as self closed plus size. Alright, and we'll do the same up here. Size, size. Move this up, set size equal to size of struct as tag end plus size. This is size. And this is size. And finally, let's do the same for this tag start thing. Size. Alright, let's see what happens this time. Huh, now it works. Almost double free or corruption. But it prints exactly what I was hoping it to print. Great. What about this double free? Because we allocate for these, assert with 0, then put into this. And here. And then we just do destroy tokens. Do we loop too much? Let's see. N is the length. And as long as we have an N, we go and we decrease. And we destroy that token. Maybe we should just do this in this case. So now we're back at this. T's is equal to T. What if we do, let's see, this and these, and we want to have the address of this plus this. Will that make a difference, perhaps? Incompatible type for argument 1 of free. Cannot convert to pointer type. Okay, now it compiled at least. But we still get that thing. But perhaps it's this line. No, it's not. What if we were to send the reference instead? Now it compiles. 8311. Maybe we should go the other direction. So we set n equal to 0, and as long as n is less than t's length, we increase it. Will that work? Who said garbage collection is easy? Maybe we should make it in 2 steps instead. So if we do something like void p is equal to and then we give this pointer to destroy token. Something like that. Let's compile at least, but invalid pointer. Well, I don't want to put in any more time in this for now. I will figure it out later. For now, we will just leak the memory. Let's make no, let's do this. So now we know that this needs to change later on. Useless type name in empty declaration. Well, that's kind of the point. Okay, so it works. We just need to figure out the garbage collector, and that we can do later. All right, so now all the prerequisites are basically done. And the next thing we're going to do is take care of our parser. So thanks for watching, and thanks for today. Sup guys, welcome to today's show. So we're gonna start by trying to fix the broken destroy tokens function, or macro rather. And I think I might know what's wrong. I think the problem is I used the same variable name here as in the body of the function. So let's see, we will open up a do block. And let's see if I remember how I did this. We had an int16 n. And then we had a for loop. So for, and we'll set n to 0. We're going to loop as long as n is less than, and this will be x dot length. And then n plus plus. Right. And at every iteration, what are we going to do? We're going to call destroy token. And we want to give this the x dot t's and this number. And when that is done, we want to free our x dot t's as well. And let's not forget all these backslashes. And at the end, we'll just do while false. Like so. All right, let's see if this works better. This is another error message than we got the last time. What if we were to do something like this instead? So let's see. We want to get it. Sorry. We want to get it x dot t's plus n What if we just do that? It compiles. No, it still does not like this. I wonder why this does not work, because all of these t's are individually allocated, because make token and all of this, its derivatives, it allocates this. Oh, wait a second. The pointer is hidden inside of here, right? HTML contents start is equal to P. That is what we're gonna destroy. So let's do that. So instead we do x dot t's, and then we do n. So this is the token. Then we want to get at the contents, and here it differs between the different types of tokens. But they should all have the same position. So what if we just use that? So if we create an additional parentheses and we take the address of this, can we do that? Seems like. But it still complains that it's an invalid pointer. Because we want to get at these. These are the pointers we want to remove, so to speak. But we don't want the address of this. We want the contents of this. But can we really do this? I'm not sure we can. No. What if we cast it to a void star? No. What if we were to assume that all of them are text tokens, for example? Because if they were, we could just do content dot text token like this. And what if we were to cast it to a text star? Because it should be able to free it the same way, no matter what kind, right? Or what type. It compiles. Double free. Why do they have the same address? It does not make sense. Contents, text token. That's weird. Let's code something that tries to check that. So let's comment this out for now, and let's do something like, well, we can do basically the same thing. And we make a for loop. Set n to 0. We loop as long as this is less than t's dot length and n plus plus, and then we do something like this. Let's also put in the index. And this should be an unsigned int of t's dot t's dot contents dot contents. Text token. And we need to let's try this. While false, like so. Let's see what we get. We got disconnected. All right. Fortunately, Sociopath is very resilient. If we just reconnect, it should be fine. Didn't I save? Oh, I need to save again, that's right. Tease.tease is a pointer. So why doesn't it complain about that in the other occasion? Oh. Let's put in the index as well. And what do we get? The same address. Why is that? Is this one of the mallocs? Let's see. Okay, this time we got another address. So, malloc. 51B0. It's this one. And why do we get that in every position? Oh, wait a second. This is a static variable. So it does not remember the other addresses. Okay, that's the problem. Okay. Do you really need to malloc this as well? And if we do, how do we store that? But why does this work if that's the case? Because we save them here. Well, you guys, I believe we need to create a real garbage collector. At least a simple enough version. Okie dokes. So let's start by defining some structure. Let's call it garbage. And let's make this a dynamic array. So what we'll have in here is a pointer p. Now we need to have an array of pointers. So let's do a double star then. And let's define the capacity. And let's define the size. So this is the garbage. Let's create a constructor for this thing. So we'll do garbage, make garbage. We don't need to have anything in here. Let's also make a definition. What should we call it? Garbage collector block size, perhaps. Not entirely accurate, but good enough. Did I make it a pointer? Yeah. So we'll start by calculating the size. Which will be the size of struct as garbage times garbage collector block size. Then we allocate this. and we need to set the fields as well. So the P will be equal to void $0. The P capacity will be equal to the block size, and the P size will be 0. And then we return this. So that's a constructor. We need a function to add stuff to it as well. Let's call it add GC. And it takes a void star. So void star pointer. First we need to assert that we have a pointer. Well, we need to give the argument of the garbage. So if our garbage size is more or equal to the garbage capacity, then we need to make this bigger. Then we need to have a size so the new size should be the size of struct s garbage times the capacity plus the block size. So we increase by 1024. So then we'll do a realloc. And we give the P, and we give, no, not the P, the G. And we give the size. We assert that we have a P. This should be G and pointer. And then we can continue with our business. We also need to update the capacity. So P, let's not use P, by the way. easier to just modify this thing. So the capacity will be equal to the old capacity. Okay, so we can do plus equals GC block size. So now we will have room for adding this thing. And the current size is the index we want to get at. So the GP of G size will be equal to our pointer, and then we will just increase the size. Simple enough. So now we can add. Now we also need to do the actual garbage collection. So we need a function. Let's just call it GC for garbage collection, and we give the garbage. So void GC, and we have garbage G. And what are we going to do? Well, we need to have an N. And we'll need to do a for loop where we set N equal to the G size minus 1. And as long as we have an N, we're going to keep on looping, and we're going to decrease this. And at each iteration, we'll simply do free P GP of N and then we're going to free the whole thing. And we need to have another of those, because when we have freed it, we need to create a new one. So we'll make garbage, and we'll return the P. So this can't be a void anymore, because we need to return the new garbage. Like so. And let's update this as well. Garbage star. And we either need to give this garbage collector to every make token call. Yeah, I think we're going to do that actually. So garbage garbs equal to make garbage, and we'll give it here, garb. So we need to update the signature of this. Make token. So here we need to have the garbage. Let's see. Now we can't simply do this any longer. We need to do something like token ret, and we'll set ret equal to this. So before we return this thing, we need to grab that pointer. So basically we need to do similar to this. So our pointer will be equal to the return contents. Let's just pick one of those. I think we can do this without a cast. But how do we update the garbage? Do we need to return that as well, or can we cheat and make it a global variable? Wait a second, there's a second option, isn't it? We can send the actual reference. And then we can just do well, it's gonna be G equals add GC, G pointer, I suppose. and then we'll just return the ret. I think this is gonna work if we modify this slightly and do this. And down here we can simply do gc g. Let's see what the compiler says about this. Void value not ignored as it ought to be. Add gc. We made this a void. Okay. So we need to do the same thing here then. We need to do this. Incompatible pointer type. Garbage. Double star. Maybe we don't need to do that. I almost never use function parameters as output variables, so I'm not very used to this kind of stuff. But we'll figure it out. Okay. P undeclared 299. Yeah, it should be G. G undeclared 354. I think we call it garb here. Okay, it compiled. Let's brace for impact. I did not see that coming. Ret is 0. We switch on the type. Now we need to break. Before we had return here, so we didn't need the breaks, but we do now. Okay, let's try again. Segmentation fault. At least something new, right? And where does it crash? It checks the string length of HTML. So basically we go to the make tag start. So it's probably this add GC that crashes then. And what do we do in the add GC? If J size is more or equal to the capacity, which it shouldn't be. So these two things is all it should do. Did we initialize this thing? Yeah, we make the garbage. And we send it to the functions. It's weird that it shows this string length, but we're not using that function. We are using our own string length. It must be this add GC that fails. Let's just try to comment it out temporarily. Yeah, now it crashes when it tries to do the garbage collection. But it's a very simple function. G P G size Before we do this, let's print the size and the capacity of this thing. So we have the G size and we have the G capacity. Size 0, cap 1024. So this is gp0 is equal to the pointer. And that's a crash, I suppose. So if we do an exit 0 right here, it still crashes. Does not. Yeah. Oh, wait a minute. I thought about this wrong. We shouldn't make it like this. We should make it like this and move it down here. If it's possible to do that. Let's see if it is. Uh, 285. All right. So this should just be PP is equal to P arrow P is equal to 0. Let's do this. Maybe this. Alright, it compiled. And it did not crash. 0, 1, 2, 3, 4, 5. Does it do the freeze? Yes, it does. Alright, you guys, we have successfully completed a garbage collector. Easy as pie. Yeah, I think that's it for this session. Thanks for watching. Thanks for today. What's up, guys? Welcome to today's show. So today we're gonna continue with our Hyperbird project, coding a parser for HTML. And the last time we succeeded in creating a functioning garbage collector. So now that we have everything in order, we will soon begin coding our Lexer, which will turn the language of HTML into our tokens that we have defined here. So I want to start by creating, let's see, if you remember this string data type, well, we created several functions relating to that. A copy function, for example, and also this get function. And I want to create similar functions for our tokens as well. So let's start by creating something that copies, copies tokens. And we can probably make a shallow copy since we have all of these individually in memory already. So it's basically only the references we want to copy. I think so, at least. Let's try it that way and see where we end up. So I want to create something like void tcopy, and it's going to take a tokens pointer. And let's see how we wrote this other copy thing. We can probably remove this. Where is it? Here, scopy. So what do we do here? We allocate a new thing, zero it out, set the length. Then we do a string copy in this case. And we set the current position. So how does our token structure look like? We have this. So it too has a length, and we have this token thing. So we need to allocate for both of these. Right. And this token is just a list of pointers, so we can basically just copy that as well. I think we can write something very similar to this. This, however, returns a string, so let's return what we make the copy. So tokens tcopy, and let's also include the garbage collector. So we'll have a garbage pointer like so. And then we can just copy this thing and alter a couple of things. So we'll have tokens, and we will have a tokens t's. Or let's call this old, by the way. And let's also add our garbage g. Alright, and we're gonna turn this p into, let's see, it's gonna be a tokens star, and let's call this new. So we assert that we have a t's, and that t's have a length. Then we allocate, let's see, the size of this will be tokens plus t's length. Should be pretty similar, right? Let's see. But these aren't 1 byte each, which they were with a string. So we need to do t's length times size of a pointer. I'm not sure if we can just put a star here. Maybe we need to do void star, but let's try this out. Then we need to allocate our new thing. which will be a tokens star. And we'll put this into this will be our new thing. And we didn't call it tease, we called it old, right? So let's use the correct variable names. And we set the new length to the old length. And this cur thing, well, we don't have a cur. So let's remove that. Maybe we can actually use something similar to cur. This can be the cur. We'll get back to that. It's not interesting in this case. Alright, so we can't do a string copy, but we can calculate the size and do a memory copy. So let's see. The size will be the new length times size of pointer. And then we will do a memory copy. And the destination is going to be wait a second, we need to allocate for this as well. Yeah. So the size in this case will only be this, right? The size of this structure as is. So we'll allocate this, assert that we have it, 0, length, and then we do this, and then we need to allocate that as well. So let's call this, this can be t. So t is going to be token malloc size. So we're going to zero out this t. Let's also assert that we have a t. Now we can do our memory copy. So we're going to copy into t the old t's. And size. And we also want to garbage collect both the old t's and the entire thing. So let's do add gc, and we give our garbage, and first we take the old t's, and then we take the entire old thing. And at the end we can return our new. I think this is going to work. We need to create our memory copy though, but that shouldn't be too difficult. So we will have a void memory copy, which will take a void destination, a void source. We can just do this. Void source, and then int 16 for the size. And we are in the wrong file, I think. Yes. Alright. So let's see, how do we do this? It's going to be a void and memory copy. It will have a destination, source, size, and we need to have an int 8p, and an n. Do a for loop where we set p equal to, oh, by the way, we need two of these. So let's call them d and s like we did before. So the d will be equal to the destination. Maybe we should cast this. The s should be equal to the source. The n should be equal to our size. We're going to continue as long as we have an n, and at each position we're going to increase d and s, and we're going to decrease n. And then we'll simply set the destination equal to the source. And that's it. This should copy this entire thing. All right. Okay, so now we have a copy. Let's double check that it works though. Let's see how to do that. Okay, in this case we made it a regular thing, not a... We put it on the stack, this token T's. Let's not. Let's create a token, tokens T's. And let's set it equal to malloc call. Let's 0 it. And then we can do the same as below. So T's length should be 6. And t's should be t. Let's just double check that it works. Okay. Conflicting types for S copy. Maybe it's void still in this. No tokens T copy. Garbage star, token star. Can't find T copy. Did I name it something else? I call it S copy. No? Yes, I did. This should be T copy. S copy we have already. Okay, that's better. Expected expression. Okay, we can't just do size of star. So let's do void star and yeah. Incompatible type for argument 1 of show tokens. Right, we need to do references. 375. I suppose. No. Maybe we need to. Yeah, I think we do. Okay, does it still work? Yes, it does. Maybe we should remove this size cap thing. Okay, it still works. So let's see if it will work if we make a copy. So we'll have two of these, one old and one new. And instead of t's, we do old, old. Old and old. And then we do t's is equal to t copy. We give the garbage and we give the old. And let's see if we get the same result. We do not. This looks pretty weird. Or maybe not. So let's see, how big is this thing? It's 2 plus 4. So this should be 6 bytes. Do we see a malloc for 6 bytes? Here. But that's probably not this thing. Malloc 8. Malloc 24. Let's see if it's our memory copy that bugs out. It should probably still crash, but maybe at a different place. Seems to be the same place, so it's not our memory copy. Then what is it? So we check that we have an old and that we have a length. We calculate the size, allocate a new thing, assert that we have it, zero it out. Let's add a printf. Just to see a little bit where we're at. Okay, trying to allocate 24 bytes. Okay, at that point we're still alive, so to speak. And the memory copy goes through as well. So what is it? Is it this? Add GC? Seems weird. Let's check. No, this whole thing works. So what happens after our call to copy? Then comes the printf. Let's do a print hex of old. Let's say 30 bytes. And of t's. Okay, so it starts kind of the same, but this does not look identical. So this is a memory dump. So the first 1, 2, 3, 4 bytes are the same. Why not the rest? Because we do a memory copy of t from the old t's. And t is the new thing. So this is, I want to see where we allocate for this. Do we have a make tokens? No, we did that manually. So we make a couple of these. And we allocate token times 6. So this is where we allocate the t that we want to copy. Wait a second. I'm looking at the wrong thing. Because the tokens structure is just 6 bytes wide. What we really should be looking at is old T's and T's. That's what's interesting, the actual tokens. And how big is that? It should be 6 times 4, 24. So basically the 6 is the number of elements. And after that we should have a pointer. So we have 1, 2, 3, 4. Well, let's see what this looks like. We can't even really print this thing. Oh, wait. I do make the copy, but did I actually set the pointer? No. So that's why. So in the new t's should be equal to t. Okay, now it looks better. But this looks weird. Assertion T type failed. The memory looks exactly the same. Let's also check just the old and the t's and see how that looks. Pretty similar, but let's see, this and 1, 2 is the length. And then we have 1, 2, 3, 4 bytes. Maybe there's a little bit of padding as well. So we'll have probably 1, 2, 3, 4 bytes of this. One, 2, 3, 4. Okay, this looks more like a pointer. and the actual memory looks exactly the same. But something goes wrong anyway when we try to access it. And that is what this show tokens does. Maybe we shouldn't dereference. Let's see, if we dereference old, does it show the correct thing? Yes, it does. So why shouldn't we be able to dereference our new T's? Because they look pretty much the same. Let's see how we do it in show tokens. So basically it's this that fails. Let's just, for the sake of testing, removing this. We get a part of it, but not everything. We get 3. Maybe I calculate the memory wrong when I copy. That kinda must be it. So it's this thing. And we do new length times size of a pointer. Maybe we should do times a token instead. And let's, by the way, optimize the structures a little bit. Since we do have an int16, why not let it take 16 bits? And same here. And let's do the same with these. Tag type. I'm not really sure about these enums, but we have 4 of these. Basically, it should be enough with 3 bits, but I'm not sure about that. But let's try it. We live to learn. Let's make this 16 bits. The rest should be okay. Okay, it works. It works. But this still takes up quite a big... No, it does not. Look at this. Now we only have 1 byte. And then we have 1, 2, 3. Maybe it pads it after a while. Did I save? By the way, should this be specified in bits or bytes? I can never seem to remember. Let's see. Specify bits, C structs. Width of bit field. The number of bits. Yeah, this is the right thing. Oh, never mind. Okay, so our copy function works now. That's great. So the next step is creating a similar to this get function, which chops off the first token in this case. And returns the new thing. In this case, we return a tuple of what exactly? Tuple, new string, and the thing we gonna return, right? So we need to define a similar tuple structure as well. So struct s, let's call this a t tuple for token. And it will return it will return the new tokens thing. So the rest of the tokens basically. Let's call this x's. And it will return a single token. X. So we type def struct s token tuple to t tuple. And let's also copy this idea of get. So this returns a tuple and it takes a string. So we'll have a t tuple and let's call this tget. And let's use our garbage collector, and we will have a tuples. No, we will have a tokens star here, like so. And let's copy this whole thing. So this will be our tget, and this will be tuple. And instead of string s, we will have garbage g, and we'll have a tokens t's. Or let's do old and new. So this 2 would be tokens, and this C thing will be token singularis. Let's call it X. And we assert that we have an old, and let's also assert that we have a garbage collector. And if we don't have any length to the old thing, we will fail. So let's see. We will set our x equal to our old t's. So that is the first token in the list. And we will make a t copy of old to get our new thing. And in our new thing, we will increase the t's, jumping past the first one, and decrease the length. We will create a t-tuple, where the new is the x's, and the x is the x. And instead of calling sDestroy, we will add it to our garbage collector. So add gc to the g and our old. Maybe we don't need that, by the way, because our copy function will do that for us. So let's just remove this. And in case of error, we return a 0 tuple. Is this all? I think so. Let's try it out. So we can remove this thing. And instead of calling the t copy, we will call t get. So if this works, by the way, we will get a token in this case. So let's create a t token. T token. And this will be tt. And what we're going to print is the tt dot x's t's. I think. And if it works, it should print the same thing as before, but omit the first one, which is the HTML thing. So let's also do something like this. Removed this. And this is show token singularis. This will be the tt.x. And then we show the rest. All right. Unknown type name t token. Yeah, it should be t token. It should be t tuple. Incompatible types. Right, this should not be a pointer. Which means we don't need to do this. Token star. No, we do need to dereference this. Maybe we'll do this. I'm not sure about the syntax. Oh, my cat is attacking me. I think we need to take a short break. Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support. Alright, welcome back you guys. Let's continue our troubleshooting. So I will do make clean and we'll run it again. Alright, let's see. Incompatible type for argument 1 of show tokens. Well, we need to dereference this thing, I think. It doesn't feel too good about my syntax though. So let's see, TTXs. Let's see, the tuple X's is a tokens star. So we need to go into the X's and then the T's, and we have the list of tokens. But we should not specify a list of tokens. We should specify a tokens structure. So that's why. Let's just dereference this thing. That's more like it. But oh, all those parentheses. Warning, unused variable 376. Which one? T's. Okay, so let's see. What did we do last? Well, we want to chop off the first token and present it separately, and then print the rest. Interesting. It kind of worked. This is right. We chopped off the HTML token, but we presented the body token. That's not right. Let's double check our tget function. And what are we returning? X is equal to X. And what is X? X is equal to the old T's. That should be the first one, no? But it's only a reference. So if we set X equal to this, and then we alter the thing, this too alters. We need to do a not a shallow copy, but the opposite. What can that be? A thorough copy? I'm not sure. And how do we do that? Well, why not just use our memcopy function, memory copy function? So into Um, let's see. Into X, we want to copy old t's dereferenced. Let's also make this like so. And we want to copy the size of the token. And how big is a token? It varies, right? Yeah, we have 3 bits here and then a variable length here. Maybe we can use our constructor function. Yeah, that's a good idea. So we probably don't even need to do memory copy. Let's make this X a pointer instead. And we'll set X equal to make token. We pass the garbage collector, and the type will be old t's type, and the value old t's contents. And then we need to know what kind of content it is, but let's just pick one. Let's see. So let's default to the text token. They are all basically the same anyway. So let's do text token, and what do we have inside of the text token? There is the int date value. So value. Quite many levels now. Maybe we need to refactor that later on. So let's see. I think this is going to work. And we'll give the dereferenced version of X. We need to change which arrow, content, and then the arrow to dot. Hit compile. Same. If we do a print on this at the time when we create it, so what are we going to print? Well, X like this, no small x. And let's do something like this so we know which one it is. And we can't just do this, by the way. We need to call show token. And now we give it the X. $144. Right, it compiles. It says body. But where is the HTML? Because if we were to print the original thing, let's see, that is the old. So let's make a copy of this and remove. And we're going to show the tokens of old instead. Doesn't it show the HTML? No, it does not. Huh. What if we don't call this tget thing? Same thing. It has probably been like this all along. We are not getting the first token. What happens to the first token? Whatever happened to the first token? Length is 6. The old t's is t. Let's check our show token function. Maybe we calculated wrong. We set t equal to the t's. And then we increase the t. What if we were to do if we create one more of these, let's say t 1.5, this too should be an HTML. We'll have 7. So we'll insert it right here. No, that's not right. This will still be T1. This is now 7. Will it show? No. Wait a second. We get to closing tags of HTML. And we've gotten that all along, as it seems. Body, HTML. And now we get 3 bodies. The BR seems to work. That is really weird. So maybe it has something to do with the static kind of stuff. Let's see all static things we have. Here we have a static buffer, but we only use this to copy stuff. And here we have a static temporary buffer. How do we use that? This is probably it. We copy it to the TMP. We point our ret to TMP and we return our ret. Okay. Okie dokes. So let's add our garbage. And let's allocate this buffer instead. So we'll create an int8 TMP. And we will allocate this like so. And let's add it to the garbage collector. And let's remove the static bullshit. And let's update the signature. Where is it? Show token. Here we should add the garbage collector. Still a lot of errors. Why is that? We didn't change much, did we? Incompatible to we need to take care of the callings as well. So let's see if we go to show token, show token. All right, inside of here. So we need to add our garbage here as well. And just pass it along like this. And here we have one, so let's just use that. And we need to do the same with show tokens. And the only call we have are these two. So let's put it right here. All right. And let's update the signature as well for our show token. So it'll be garbage star. And now I believe it shall compile. Almost. Too many arguments. All right. Go to number 40. This should be GC. G undeclared 415, and that's right, 415. In main we called it garb, not just G. Alright, that's better. So how does it look now? Body, 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 HTML, HTML, still. Let's see if it, yeah, it must have. Why is that happening? Let's go to the show token again. We create this buffer. We add it. And we copy some things into it. And where we just copy it to the TMP and we return it. And how does the calling look? We use P and show token. Could it be this? Let's try commenting this out. I'm not sure why I put it there. Nope, that's not it. We string copy into cur. And cur is pointing towards the buffer. So this is the output buffer. And what do we print? Well, we print P, where P is the return value of show token. If we go to the show token thing, and we print each step of the way, so to speak, and what are we going to print? Let's print the ret. Body, 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 hello world, BR, HTML, HTML. Let's move this up a little bit. Let's try just doing t.contents text token value. body, body, body. So there must be something wrong when we create the token. It's the only possible thing. Make text, blah, blah, blah. And what if we print it here? So let's just do this. We print the value. HTML body. This is the right thing. So the value is okay. PTR. This is not the problem. What if we put it here then? And we want to print the well, the ret contents. Let's do this. Value. This is okay. At this point, everything looks as it's supposed to. So this make token is returning the right thing. X is equal to make token G alt is type alt is contents text token value. Oh wait, this is tget. I want to check the other function. What if we at this point tries to print the thing? So we are interested in T contents text token value. Body. This should be T1, I think. It contains the wrong thing. And if I print it here, T1 contents text token value. HTML. So this line is the exact same line as this, right? But up here, it is HTML. Down here, it's body. So there must be what if we move it down 2 steps? Now it's body. Okay, so somehow this is overwriting the contents of this. And that is our problem. So how do we fix it? Well, let's go to the make token to begin with. So this is where the magic happens. And then we go to make tag start. So what we do is we allocate a new token, we zero it out, we do a string copy into that new token's value from the value that we are passing. And then we create a static thing. All problems stem from the static things, doesn't it? I think it does. Well, well, well. And that also explains why it's only affecting the tag start, because there are different static variables for the different things. All right, at least it's a logical error that we can understand. So how do we fix it? Well, we need to allocate this thing as well, I suppose. But I don't really want to do that either. At least now, I don't want to alter 4 different functions. We have a T copy, but it's only copying the tokens pluralis. And we need to copy a single token. No, I think the best way is to alter this thing anyway. So how can we figure out how big this is? Well, it's a fixed size, isn't it? Because we always have the 3 bits of token type, and then we have one of these, and all of them are pointers. So that should be pretty simple, actually. Maybe we can even use the same code for all of them. If we use ret to allocate, well, we can reuse our size. And this will be size of struct s token. So then we set ret equal to a token star malloc the size 0. And what are we gonna change? We are going to set the ret type to tag start in this case. And we're going to set the ret contents start to p. Let's add this to the GC. Remove this. And this. Okay, we can basically use the same code everywhere. We only need to change a couple things. The type, this should be tag end in this case. And this should be end. The rest should be pretty similar. So let's do the same here. Type is self-closed. And this is self. And then we'll do the text token as well. Like so, and we also need to add the garbage collector. Like this. And here we already have it, which makes things easier. We can just pass it along, thread it along. And let's not forget to change the signatures as well. All right, let's see. 260, wrong file, 260. Contents dot star. Same here. And here, and finally here. G undeclared 284. Yeah, maybe we should give it a name, right? Right, it compiles, and now it looks like it should. We do have two HTMLs in the beginning, but that's because we did add that to the main, like this. It's T15 here. Let's remove that so we have the correct data. So this will be removed, and we'll do 1, 2, 3, 4, 5. And this is not 7 anymore, it's 6 and 6, like so. All right, now it looks like it should. Let's see if our function works now, this remove function. So we can get rid of this, and we can uncomment this. And if everything works, we should chop off the HTML in the beginning, print it separately, and then print the rest. Incompatible type for argument 1 tt.x. Show token. We added the garbage collector. Alright, that's better. Let's see. Okay, we chopped off HTML, and the rest is here. And now we have every single piece that we need in order to begin the lexing and parsing. Pretty nice. Pretty nice. Let's find this printf, by the way, and remove it. This one. Great. All right. Thanks for watching. Thanks for today. Sup guys, welcome to today's show. So today we're going to continue our HTML project, and I intend to begin coding on the Lexer. I only need one more utility function, and that is a cons function. So basically we want to return a tokens star, and let's call this let's call it tcons in case we want to create different kinds of stuff. Let's give it a garbage collector, and it's gonna take a token as well as a tokens pointer. So basically what a cons thing do is it adds one token, in this case, to our list of tokens. Right? So let's code this thing. I want to disable this caps lock. I did that actually on my Mac, because there I have a very advanced keyboard that I can reprogram the keys, and that's not in software. It is in the the hardware basically, or at least some software inside of the keyboard. Anyhow, let's go to our cons function. As soon as I'm able to go past that caps lock, it haunts me. Totally useless key, actually, the caps lock. The only time I use caps lock is when I accidentally push it when I'm coding. So it's only a nuisance. Anyhow, let's say we will have a tcons with a garbage collector. And what else? A token. and the tokens star. And maybe we should give names as well. So this will be G. Let's call this X. And let's call this X's pluralis. All right, how do we create this thing in a good enough kind of way? Let's see. We need to create a new token, don't we? Make token needs a token type and all of this stuff. So maybe we should call this old. And then we create a token star, which is the new one. And let's assert a couple of things. We want to have a G and an old. Can probably do that, by the way. We need to have an old dot type, and we need to have an access. If we do, we want to create a new token. And the new token will be created using make token. We give garbage collector. We need to give it a token type, which is the old type. And we need to give it a value, which is the old dot contents dot. Let's use text token. They're all the same. And this is a pointer, and we need the value. So this should make us a new token. If not, we'll return 0. Otherwise, let's zero out this new shiny thing. Or let's not, by the way. It's zeroed automatically. Alright, so now we have a new token. We also need a new axis, don't we? So maybe we should call this differently. Let's call this X as I did from the beginning, and this axis. So this will be X prime, and we will have a tokens axis prime. So the prime is the new one. So we have G, we have X type and X's. The X prime will be make token from the X type and the X value. And if we don't have an X prime, we return 0. And how do make what does make tokens take? Don't we have make tokens? I thought we did. We don't. So how do we make tokens? Alright, we malloc it manually. I think we need to make tokens as well, don't we? Length. And how do we make the T? We malloc a token star. Well, let's see. So make tokens will return a tokens. And it will probably use a garbage collector. And what will this return? We want to create something which creates an empty token structure, which means we don't need any more arguments to this. Right. So tokens star make tokens garbage G, and we need a tokens P and a no, we don't need that, by the way. We'll assert that we have G and the P should be equal to, we need to calculate the size. And the size will be size of struct s tokens. P will be a regular malloc with this size. Let's assert that we have a P. Or maybe not. Let's check if we don't have a P, and in that case we'll return 0. Otherwise we will zero out this thing. And we want to explicitly set the different fields, which are length and t's. So the p length is 0, the pt's is a token star 0. And we return p, like so. So now we will have two different scenarios. If our old axis has a length of 0, then what do we do? Then what do we want to do? Let's create a tease as well. well, after this function has run, we will have the length of 1, right? So basically we want to set x's to make token. Give it to G. By the way, I almost forgot. Let's also add this to the garbage collector. Add GC. Add GC. Is it GC add? Weird that it doesn't give me the signature. Anyhow, I think it's the G and then the pointer, right? Which in this case is P. Alright, so we make an empty token structure. That's our axis prime. But we're gonna set x's length to 1. We're gonna allocate t's. Let's create the size as well. In 16 size. So size will be equal to size of, let's see, how does this look? We have the token, which has a type, and then we have a pointer to the actual token. So let's just do the size of struct as token. And we malloc for our t's. Yeah, I think this is right. So t's would be malloc size. And we'll zero the t. And now what? Well, we have room for one thing inside of this t's. So we'll set it to the x we created above. And x is, our new x is t's, will be this t's. And that's basically it, I guess. Let's also add our old add GC, our old access to the garbage collector, and then we can simply return the new thing. which is our axis prime. So that's the case if we have an empty list of tokens. But if we have a current one, then what do we do? Well, we want to make a copy of the thing we have. So let's set access to t copy with the garbage collector and our current access. So then we have a copy of it. Now we need to increase the capacity of the t's inside of that, which means that our t's will be equal to the old t's. No, it will be equal to we need to calculate the size first. So basically, the size will be equal to the size of let's take the length of this thing and increase it by 1. So then we should be able to take the size of a struct as token times the new length. So now we can set t's to token star realloc, and we give the old one, which is x's t's, and we give the new size, which is size. If we don't have t's, let's just return 0. But if we do, we're going to set our axis dot axis dot t's to our t's. And let's also add to our garbage collector our x's. And then we'll return axis prime. Okay, I think this is going to work. Let's try it out. I want to create an entirely new main, so let's comment out all these things. So we'll have an int main, and we're going to have a token, let's say x, and we're going to have a tokens axis. We'll set axis to make tokens. We need a garbage collector as well. So garbage g is equal to make garbage. And axis is equal to make tokens, and we give the g. That's it. So So now we have an empty token structure. By the way, if we try to print an empty structure, show tokens, will it crash? Let's make sure it does not. So let's assert that we have a G and a T's and a T's length. Just to make sure. Okay, so X's contains an empty structure. We want to create a token. So let's say that our X is equal to make token, tag start, HTML. And then well, we should be able to do X's is equal to tcons G X X's, which should add to this structure. And let's see if we can print it. So show tokens, and it takes a garbage collector and a dereference token structure. Return 0. Simple enough. So if this works, it should print an HTML tag basically. But I suppose we need to remove some errors as well. Yes. Returning token star, blah, 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 from a function with incompatible return type, token star. Oh, 13. This should be tokens pluralis. X's is a pointer, did you mean? Yes, I meant that in every occasion. So 14, X's arrow tokens, X's arrow length. Same here. Why don't they make this dot and the arrow interchangeable? Alright, error incompatible types when assigning to type token from type token star. 20. So T's is equal to X prime. Maybe we should dereference this as well. Which reminds me, down here I allocate for the size, but I don't really add the token, do I? So I should do something like x's prime, t's, and then I need an index, which is the old length. That should be the new index. So it's x's length, and that should be equal to the x prime dereferenced, I think. Let's try. Is a pointer? Yes, it is. Did you know that I made a book about computer networking? You will learn how the internet works and how everything works under the hood. It's a complete beginner's course, but it has some advanced elements as well. And you will learn network design and network security and all different kinds of stuff. For more info, check out books.drbirch.com. That is books.drbirch.com. Thank you for your support. All right, welcome back. Sorry for the break. I have ordered 3 times 12 meters of fabric, which just got delivered. I'm gonna create a recording cube inside of my office to remedy the echo. Anyhow, let's continue with the troubleshoot. Don't really remember where we were, so let's do make clean. Let's jump down a little bit, clear the screen, run make, and boom. Right, invalid operands. So the T's seems to be the problem, yeah. This is 46. Right, because we send this as a dereferenced structure, not a pointer. So I think this will suffice. Incompatible type for argument 2 of tcons, token star, and it's expecting a regular token. So let's just dereference that. 440, it's right here. So let's give it star x instead. Simple enough. And now, ladies and gentlemen, I believe it will compile. All right, so it compiled, but will it work? Will it be able to create the structure with our HTML tag? Seems like. Very nice. What if we have 2? So instead of just x, we have an x2. And x2 is equal to make token g tag, let's say it's a self-closed, and br. So we run this again with tcons g, x2, and x's. So if we run this, right, we need to make this an int 8. It works. It works. Nice, nice, nice. Now that we have all of these different utility functions, it will be pretty simple to write the Lexer. So let's see. I think we're going to create a new C and a new H for that. So let's create a Lexer.c and a Lexer.h. Let's also modify the makefile. So we will have a Lexer.o, which depends on Lexer.c and Lexer.h. We want to run cc with the flags and create this. When we compile the entire thing, we want to include Lexer.o here. I think this ought to be enough. Maybe we shouldn't call the all phony after all. Let's not do this either. Alright, let's just see if it builds. Yeah, looks nice. Okie dokes. So let's see. This one includes hyperbird.h and tokens.h. Maybe we should create a pragma. So if we do pragma once, this can only be included once. And let's do the same here. So pragma once. And we can close our makefile. And let's put the Lexer here and the Lexer H here. And let's also do the pragma once here. Then we should just be able to include our stuff here. So we want to include our hyperbird.h, but also our tokens.h. And I suppose we also need birchutils.h. And if you don't have birchutils, you can download it from the repo at repo.drbirch.com. Okay. So let's see. Our Lexer will not export a lot of functions. We will basically only have something like, well, we want to have a function called Lexer, which will return a list of tokens. And what will it take as input? Well, a string. And that'll be one of our own string structures. Yeah. And we get a couple of errors here. Maybe we should move this stuff. Here. So we don't get those. But in order to write this function properly, we also need a couple of other things, like a garbage. No, wait a second. I think I'm going to do this instead. I'm going to have a second function, Lexer prime. And this will use garbage, string, and it will also have a tokens star. So basically this first Lexer thing will initialize this second Lexer. And it will gradually build this tokens structure and then return it. Yeah, I think that's the thing. So let's start building this function. So it will return a token star, Lexer, and a string s. And what will it do? We need to initialize those different things. So first of all, we need a new garbage collector, and we need a token structure that we're going to build on. Let's call it x's. And we need to assert that we have a string. Let's also assert that this string has a length. Yeah. Or maybe not, by the way. Let's assert that we have a string. And then we can have an if statement about the length. And in that case, return 0. I think that's better. All right, so let's initialize our garbage collector. Let's make some garbage. And let's initialize our x's as a make tokens with RG. Maybe we should add a feature inside of our make garbage. Let's see, it's in our, this one, make, no, not make garbage, make tokens. Let's do, if we have a G, then we add this to the G. So we don't necessarily need to assert that we have a G, because we're not passing it to another function. In that case, it doesn't have to garbage collect. And in this specific case, I don't want to garbage collect, because we're going to return this x's, and I don't want to accidentally free that thing. So let's just do garbage star 0. And let's check that we have a G and an x's. Let's do this. If one of them are missing, well, let's do this. If we don't have a G, but we have an x's, we want to free the x's. And we want to return 0. If we don't have an x's, but we have a G, we want to free the G. And return 0. So everything is properly done. And now we can return our Lexer prime, initialized with our garbage collector, our string s, and our x's, like so. Very nice. So now we're going to write the Lexer prime function, which will probably be the most advanced and messy function this far. So token star, but it will be much easier than it would have been without our utility functions. So we have a garbage G, we have the string s, and the tokens star x's. All right, so this will be a finite state machine. Which means we need to define the different stages. So let's call this the state, E state. And let's have a non-state, which will be the first thing. And let's see. So what are we going to do? We're going to read one byte at a time. Gonna read one byte at a time. If it's one of those, we want to start reading the contents of that thing. So let's say we have a state called new token, where we wait for a new token. And then we have a read token, where we are reading contents of that token. And we're going to flip between the two. Maybe we should call this stage after all. And let's create another structure for the state, where we have stage. Okay, we need to move this down. So we have a stage, but we also need to know a type of token we are currently reading. So we need to have a token type. And we need a buffer. I think that's it. So let's type def this, struct s state, and this is the state. And we'll pass along this state as well. Let's make this a pointer, and let's create a constructor for that. So it will return a state, make state void. So state star make state nothing, and we will have a state s the size is equal to the size of a struct s state. We allocate this. We assert that we have an s. We zero our s. And we return it. So let's create one here. State. And the state will be equal to make state. And we will give it to our other function. So we will have a state star state here as well. And let's update the signature. Seems like I did. So let's switch on because this function will be called over and over again. So let's switch on the states stage. So we have a case none. We have a case for new token and read token. So new token and read token. And then we have a default. Well, here we'll return an error. And this break is unnecessary, but I like to have one. All right. I wonder if this none state and the new token state will be the same. Maybe we should, at least for now, set the stage to new token from the beginning. And let's not use this none at the moment. Maybe we need to initialize some stuff there later on. And what do we need when it comes to variables? Well, we are going to need to have something for the token when we have successfully read it. And we need to have a single char. Maybe we need 2 of those. So the first thing we want to do is we need a tuple as well. So the first thing we're going to do is we're going to create a tuple using our get function. So this will give us 2 things. Let's also have a string s prime. So we'll get the char inside of this tuple, I think. Let's see. This is in Hyperbird. Tuple. Yeah, we have a string and we have an indate. So we'll get a, let's see, this get function, what does it return? A tuple, not a pointer. So let's do this. And our s prime will be the tuple dot s. So this we'll do every time we call this function. Chop off a single char. And what happens if we are done with the string? If it's empty, what will the get function do? Not tget, this get. So we assert that we have an s. If s length is 0, we go to fail and we return 0 on everything. So basically we can do this. If c and s prime are both 0, so then we're going to do something, but let's wait with that. I think I'm going to need a peek function as well, which doesn't chop off one of these things from the string, but it will just look at the next thing that will get chopped off, so to speak. So this will return an int 8. Let's call it peek, and it takes a string. We'll add this to the Hyperbird file. So int 8 peek string s. And if, let's assert that we have an s. But if we don't have a length, so it's empty after this, or before this, then we return 0. Otherwise, we return the s cur. Simple little function. All right, so what are we going to do? If we are expecting a new token, so let's say C is equal to this. Then we want to peek at the new string. And if the CC is equal to slash, then we know we have an ending tag. So let's do a token type. And we'll set this type to tag end. Otherwise, we either have a start tag or a self-closing tag. And which one we have, we don't really know yet. So let's set it to a let's set it to as tag start, and then we can alter it later on. And if it does not begin with this, and we are expecting a new token, then it must be a text token. So now that we know the type, we can change the states. Didn't we put a type in there? Yeah, token type. Isn't it called token type? Or is my VS Code just flipping out? Token type, small t. So the type should be equal to the type. And let's zero out the buffer. We do also need a cur, so we know where we currently are. And let's say from the beginning that our cur is nothing. Let's do this inside of here instead. Just to make this clear for everyone. So S cur is 0, S stage is none, S type is 0, and we return this. And now that we have all the different parts, we can recurse. What is this linked to? So we'll return ourself, Lexer. We pass on the garbage collector. We pass on the new string. And the tokens. And the state. Okay. We also need to change the state to read token. So state stage is now read token. Read token. And when we are reading a token, we first want to check if the C is equal to a slash. We have already handled that, so we will just move on instantly by recursing again. S prime X is state. Don't need to change anything. Otherwise, we want to read, we want to put what we have. Wait a second, we also, before we recurse, we want to set the state's cur equal to the state buff. So we start from the beginning instead of there. And before we do anything, we want to check that we are not overflowing the buffer. So if the state cur minus state buff, maybe we need to do this. So the difference between the two is the number of bytes we have read so far. And if this is more or equal to 254, let's say, then it's a parse error, because no tag should be more than 254 bytes. So we'll just return a 0. We are allocating a bunch of things. We should add it to the garbage collector. So the X's we want to preserve. But we have a couple of other things. The state, for instance, that should be added, because the state should be cleaned out when we are done with the Lexer prime function. We should also add the old string to the garbage. So when we create a new instance of the string, we want to remove the last one. The state will be the same all along. The tokens when we change the token structure, we can add that to the garbage collector. All right. So if the buffer is okay, we want to copy the byte we read into that buffer. So we take the state cur and increase it. And we set it to our character. And then we recurse. So we return Lexer prime, we give the G, we give the S prime, we give the X's and the state. That's it. We have another if condition though. If C is either equal to a close tag or C is equal to, maybe we should do one case at a time. So if we get a closing tag, and our state type is equal to either a tag start or a tag end, or a self-closed. Then we have successfully read the token. So let's create a token. Our T will be equal to make token, and we give the G and we give the type, and we give the buffer with its contents. If we don't have a T, we'll return an error, but we should have. And if we do have a T, we want to create an access prime. So a tokens access prime. Our access prime equals make token. No, we will do the tcons. So we give the garbage collector, we give our brand new token, and we give the old access. If we don't have an access prime, we'll return error. But we should have. This should be here, right? Okay, so what are we going to do in this case? We're going to zero out our state buff. We're going to set our stage to new token, because now we want to read the next one. Our state cur will once again point to the beginning of our buffer. And now we can recurse. The important thing here is that we pass on the x's prime and not the x's, because we want to build one token at a time, right? But we need to figure out if it's a tag self-closed or a tag end, or if it's a tag start. Well, tag end we know. But is it a self-closed? And how do we know that? We basically need to compare with our list of different tags. Either that, or we can somehow utilize, because a self-closing tag in our syntax will always look like this, a space and this thing, this slash before this one. Let's also do a check. If the C is equal to a space, then we can peek. And in case the CC is equal to a slash, so we have a space and a slash inside of our tag. In that case, we can set our state type to self-closed and recurse. So GS prime x's and state. So we will basically otherwise ignore the space inside of a tag. Right, it should be inside of a tag. So if we have a space and the let's see, and the type is not equal to a text token, in that case we want to do this. Otherwise we'll just carry on with our business. Alright, starting to take form. Let's take a short break. Alright guys, Welcome back. So, before the break, we were working on this rather big and complicated Lexer prime function, and we will continue where we left off. So, let's see. So, if we're going to take care of a new token, and the first character is a bracket, then we peek at the next character. If it's a slash, then we can select tag end as the final type. Otherwise, we will set tag start as the preliminary type. It might change. And if it does not begin with a bracket, then we can set the final type to text token. Simple enough. And then we just copy the rest, one character at a time, into our buffer, using our cur pointer to point at the next location. And we change the stage to read token. So let's see, and then we recurse. All right, so this is okay. And when we are reading a token, we want to check if the current byte is a slash. And in that case, we just move on, because we have already handled that case. If it's a space, though, and the type is not a text token, so a space inside of an HTML tag, then we want to peek and see if the next character is a slash. Because remember, we do have these self-closing tags that looks like this. So that's why we do this check. In that case, we can change the preliminary type. We can change from the preliminary type that we set up here, tag start, and we can change it to a self-closed, because now we know it's a self-closed. And we move on. And if we encounter a closing bracket, then we first want to make sure that we are either handling a tag start, tag end, or self-closed. So an HTML tag, not a text token. If so, we can create the token, because now we have everything needed. And then we add the token to our list of tokens. We reset the buffer and all the stuff, and we recurse. If we are, if we're reading a token and the token is wider than 254 bytes, then we return an error, because that's too big. We can't handle that. So we need to take that into account especially with regards to the text tokens, because sometimes you can have a lot of text, and in the current version of the code we will not be able to handle that, but we won't be needing that. And if we were to need that, it's simple enough just to increase this. We need to increase the size of the buffer as well then. And then we, let's see. Yeah, we increase the cur so it points to the next location that we are going to put stuff into. And then we set that byte to our character and recurse. So we have handled most of the cases. Is there something left to do? Well, when the string is empty, then we are done. So what do we do then? Well, we want to return our token. Is there anything else we need to do? Let's see, we need to clean up a little bit, but I think that will be taken care of anyway, because we have added our string to the garbage collector. And before we go into this function, we have also handled the state. The tokens we don't want to garbage collect, do we? Well, yeah, we kind of do, because we are, each time we add a token to our list of tokens, we create a new tokens structure. So basically, when we add a token, so let's see, down here, we create this x's prime. So when we have created our x's prime, then we should add the old x's to our garbage collector. So we allocate a new one and remove the old one in the functional style. But in this case, all we need to do is return x's. All right, it'll be interesting to see if this is going to work. There will probably be a couple of errors, as always when we create advanced messy functions like this, but it's not that messy actually. It's pretty clear what it does, even though it's a bit of a tricky function. And we make use of all of our different utility functions and structures and stuff that we have prepared in the earlier episodes, which makes this easier to write. Okay, so let's see, how do we test this? First of all, we need to create, let's save this first. let's go into this and let's remove our current main. Let's make a new one. So first of all, we need a string. And how do we make a string? If I remember correctly, we have a constructor for that. Yes, make string, and it takes a regular int8 string as an argument. So that's simple enough. Let's set s equal to make string, and we will give this HTML and body ABC BR CD CD CDE and then we close body and we close HTML. Alright, so this is our example thing. And then we need a a tokens structure. So tokens x's, and so x is equal to our fresh function Lexer. And what is let's do this, by the way. Let's go to the top and include Lexer.h. So we get a little bit of help from VS Code. So now if we do Lexer, we should get, that's right, we get the signature. And all it takes is a string, S. And when we have that, we can just print this thing, right? And then we use show tokens, and this takes a garbage collector, so we need to create one, garbage G equals make garbage. Alright, so we give G and then we give the dereferenced x's, and then we return 0. Alright, we need to edit one more thing, I think. Let's see, we return Lexer prime like this. Maybe we should do one other thing. Let's see, we have this tokens x's. That we give here. We do also need an x's prime. So let's set that to this. And then we can run our garbage collector. So we run gc on G, and then we return X's. So everything is clean, nice and clean. And let's see if we can compile this thing. So we make clean, we jump down a little bit, clear the screen, run make, and boom! Unknown type name is stage. And this is the only error. Uh, 12 in Lexer H. Right, we need to add the enum here. So now we will probably see the rest of the errors, I suppose. Yes. But not that much. Error text token undeclared. Did you mean S text token? No, I did not. 79. 78. 79. Let's see. It is 79. Okay, so it's not called text token, it's just called text, perhaps. Seems like. Oh, look at all these messy colors. I dream back to a world where GCC and GDB did not have any colors. Let's see, error, text token undeclared again, 92. Do we have any more of these text tokens? Nope. Returning token star from a function with incompatible return type tokens. Oh, token singularis 106. This should be tokens, and this should be tokens. And this as well. Okie dokes. Let's try this again. Okay, 110. Invalid operands to binary. Oh. 119. No. State cur minus the address of state buff. Why can't we compare those two? What if we were to cast this to avoid star and cast this to avoid star, just to signal our, what's it called, purpose to GCC? Okay, that's better. Control reaches end of a non-void function, 133. All should never get there. So maybe we can just move this thing. Something like that. And now I believe it will compile. But will it work? Will it work? No, no. Okay, this doesn't say much. What about L trace? 4320. 4320. $46. What can that be? Maybe this isn't what is crashing. Let's fire up GDB. Need to copy paste so we get rid of all the annoying colors and stuff. Let's define this F in case we need to run this a couple of times. Let's also define XX as x/30i EIP minus 20. And alright, start this thing. Oh, let's learn F and then start this thing. And let's just let it run for once. Okay, in peak. That's surprising. So let's see. We move into EDX from the location in EX. Infrareg EX. This does not look right. Let's do this. I think it looks kind of like a string, but I'm not sure. So let's try to print it. maybe let's check out the peak function. Where can that be? Hyperbird perhaps? Peak. It's a very simple function. If it does not have a length, we return 0. Otherwise, we return whatever the cur is pointing to. How can that possibly crash? So let's see. We do this, and then we return. So this is the last step. And we compare this to whatever's in AL. It looks a little bit weird though, since AL is a part of EX. But we probably does not run this code. So I think we are here. This is weird. Could it be? No. Let's do something like this. Let's print what scur holds. And this should be this. This should at least give us a little bit of more information. So let's minimize this. BG. Well, this looks like a proper address. This looks Weird. Okay, so it points to something completely weird, and we can't even read that part of the memory. That's why it crashes. But why does scur end up there? So let's search for where we modify this cur. Here we said it's 0, but it's not 0, so this can't be it. Here we set it to the buffer. And here we set it to the buffer. Here we just read from it. And here we increase it. So we do a first peak, and the second peak fails. So let's follow the peaks. So this is where we have a new token. This is basically the first thing that happens. Here we peak again. Wait a second, we peak at S. And we have probably uninitialized S by then. We should probably peak at S prime, right? Okay, let's see. Double free. This is probably, we do a couple of free in a row. So this is probably at the end of the Lexer function. Maybe we should improve our garbage collector and make sure that we do not have any duplicates. How do we do that? We need to, let's see, we need to modify the add.gc function. So before we add something new, we want to check if it's already there. So let's see, that should be simple enough now. We have a G size, that is the number of things in it. So let's do something like bool exists. Exists is false. Then we do a for loop. We set n equal to 0. We run as long as n is less than g size, n plus plus. So if g p nth index of that, if that is equal to our pointer, we can set our exists equals to true. And we can break. Otherwise, we go carry on. And if exists is true, we return. Should work, I think. Okay, so it's not our garbage collector that causes this. And we don't have a lot of other locations where we free stuff. I can only think of one, and it is this. So let's see, if we don't have a G, but we have an X's, we free X's. If we don't have an X's, but we have a G, we free the G. Well, we should always have a G because make garbage should never fail. What about X's? That should not fail either. Do we have any more of these free? We do not. Could it be somewhere else then? Maybe something related to strings. If we search for free. We free the garbage collector itself when we run that. So maybe that has something to do with it. Let's see. Here we run the G. Maybe we should do something like this then. But I'm not sure if that's the problem. Nope. Let's see what GDB says. It is our garbage collector. So the only possible thing is that something else is freeing what the garbage collector should be freeing. So let's see, we search for free, but we have destroy functions as well, sdestroy. Our get function destroys our string, so that's probably it. Because we add it here. And that's not really necessary. But we still want to free the last string, right? So before we return x's, let's add it to the garbage collector. I think this will work. Thank you, GDB. All right, let's see what happens. Assertion G and TS length. Line 47, Hyperbird. Show tokens. Well, I'm pretty sure we have a G, right? But just to be sure, right, so it says we don't have a length. So we return 0 tokens. I think we need to add a couple of debug messages to our Lexer. Let's see when we actually succeed in creating a token. We can print that. Let's print the token type as an integer and the value as a string. So we have the T type and T content, let's say text dot text token value. Okay. Maybe we should do this check first. Something like this. All right. What does it say? It does actually not create a single token. That's disappointing. So it never finds the end of the tag. Or it returns an error. Maybe we should check if it does. So if we don't have an axis, but I don't think that's the case. No. Right, let's do something like this. It will be rather loud and messy, but it will give us some clarity. Okay, we are actually reading stuff at least. HTML and then this. So why doesn't that trigger? If type is tag start, tag end, or self-closed. Let's see what it is. So this will be the stage, no, type. And let's, where do we have the types? Here. All right, let's see what it says. So from the beginning, it's 0. That's expected. But then it turns into 2. Probably when we read this, right? What is 2? Tag start. So when we read this, the type is tag start. So this should basically fire, because C is equal to the end bracket and the type is equal to tag start. Does the make token fail? But then we would have returned an error. We do an else if here. Is it possible that this is triggered somehow? No, it can't be. This is just space. Or state is text. But no. If it is space or state is text. Or it's not. What is this? So if C is equal to a space, or the type is not text, we should have an and here, right? Okay, we got a little bit closer. String copy, assertion, source and destination and size. So we're trying to copy the buffer and it thinks it's empty, but it should contain HTML. Oh, wait a second, we don't have a null terminator, do we? Yeah, yes, I think we do. Let's also print the current buff then. So that would be state buff. Okay, it's empty all along. What about cur? So it points to this address, which is probably the address of buff. And then it increases. It increases by one, by one, by one. Okay. Why doesn't buff grow bigger then? Here is where the pointer increases. And then we set that byte to this. But the buffer does not change. Is it possible that we overwrite it somehow? In this case we zero it out, but that's only when we have a new token. Here we do also zero it out, but this is after we have successfully created a token, which we haven't. So this can't be the place where it bugs out. What if we print the buffer right here? Directly after we have put something into it. Empty, empty, empty. What if we were to do something like nope, that's not it. It's a weird address, but Maybe not. Let's print the address of that buffer. So buff is 84, blah 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 18, and cur is the same. Weird. What if we print the contents of cur? Well, it must be the same as this, right? But we need to try something. Cur is H, but buff is empty. And cur is this address, buff is this address. Cur is H, buff is not. This is really weird. Probably it's something very easy that you have spotted long ago, and I just don't see it. What if we just check the first byte? Empty, 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 empty. Let's print it as hex then. Zero, zero, zero. Wait a minute. Is it possible that the first byte of the buffer is a 0 and that's why this happens? Let's try printing the second byte instead. Right, that works. Okay, now I know what I did wrong. Very lame thing. Because I zero initialize the entire buffer, right? And what do I do then? I increase cur and then put the byte in there. Which means that the first byte is always a 0 byte. So if we try printing the string or calculating its length, whatever, it will be empty. What we should have done is this. Okay, we create 2 tokens. We are getting closer, but now we do a double free again. So the HTML is okay, the body is okay. Then we fail. And the third is a text token, I think. Is it not? HTML body ABC. Yes. So something is wrong with the text token. Right. We haven't handled that case yet, right? We check for this and then we create a token. But we need to handle the text token case separately. So if the state type is a text token, what are we going to do? Well, we need to peek, because the only thing that will end a text token is, well, 2 things. End of file or a new tag. So let's peek at the S prime. How do we check for end of file in this case? We need to check if S prime is empty. So if S prime length is 0 and we are handling a text token, so if this is the case, or if we peek, and the result is equal to a new tag. These are the two cases that will result in the end of a text token. Alright? So in this case we should basically do this, at least some parts of it. So let's copy all of this stuff. It will be a little bit of duplicate code, but let's do it anyway. We can push it in one step. Alright, so if this is the case, then we create a token. I think this will basically be the exact same code. Maybe we can cut it out into a macro later on, but not right now. Maybe this is enough. Okay, we're getting there. HTML body B, B, and D. It should be ABC. What should it be? It should be ABC and CDE. So we're only getting the middle part of it. But it works with the tags, but not with the text token. So what do we do differently? So this code is copying the data, and it runs in the middle part, but not first and last. So when do we switch to a text token? Here. When we are reading an HTML tag, we are not copying the first byte because that's the start bracket. But when we are reading a text token, we should copy the first byte. So before we recurse, we need to check again if type is text. Then we should set our state cur to C, and we should increase cur. So now we have handled the first byte. What about the last byte? Okay, so before we create this token, we need to do the same thing. Yeah. So we set cur equal to C, and we increase cur. We don't really need to actually, but let's do it for brevity. All right, let's see what happens. Okay, now we get ABC and CDE and the rest of the tags. That's nice, but we still get a double free. What are we trying to free? A0. A0. Is it A0 this time too? Yes, maybe we can grep for it. Maybe I can spell. And now it changed, of course. No? Okay, the prefix changes. So 86, 28. Let's grep for just this part. No? 28, 9, A0. 28, 9, A0. Let's just check for 8, 9, A0. 9, A0. A0. Okay, here we go. So 25 A0 in this case. Okay. So this is something that we realloc. We don't realloc a lot, so let's see what that might be. Realloc. Here is, okay, it's in the tcons. Is that the only place? The garbage collector itself does also realloc. So tcons and that thing. Well, tcons, what does it do? It adds a token to a token structure. And we do not add the token structure to our garbage collector, except for the old ones, right? Yeah, we add the old X's. Maybe we shouldn't. Because tcons takes care of that anyway. Yeah, let's not. So we need to remove it here, but also in the text token. This is the text token. We need to remove it from the tags as well. So like this. And maybe it will work. No. Still double free. So it's probably not this that is the problem then. Then it must be the garbage collector itself. Maybe we should check with GDB and see in what function this happens. Maybe we can get a stack call trace. So let's see fg and we run f and we run start. Main Lexer gc. okay. So it is when it's freeing itself. But that's weird. Because it frees itself, but then we create a new and we return it. Why does it become a double free? The only possible thing is I would have added the garbage collector to itself or something, but I don't see how that's possible. Let's cheat a little bit. If I remove this thing, it will leak memory, but I just want to see if it would work without it. No, it wouldn't. So it's this line that double free something. So basically we're adding something to the garbage collector that we shouldn't. And that must be a token structure. So let's check all add GC in Lexer and see if we do that. So here we add the state, here we add the string, here we add x's, but we tried remove that. And then we're back here again. What about inside of here? Here we add x's. Maybe we should remove it here. What else do we have? Here we add x's too. So this is the case when x's is 0. And we add the first one. Then we add it to the garbage collector. The next iteration, we do it again. Maybe this is the one that shouldn't be there. What if we take both of them away? Weird. Maybe this shouldn't be here. What is old? Old is a token structure. What about this? Make tokens. This could be it. But it's not. What did GDB say? Main Lexer GC. So it's the Lexer, not the Lexer Prime. So it's here. Could it be that this axis is somehow ending up inside of the garbage collector when it shouldn't? maybe we could do something like let's find this GC function. Here. So what if we were to do something? I'm not sure if this is possible, but let's try. No, we don't need this. So if GPN, then we free. Can we do that? We can, but it does not help. Maybe these are two different errors. And when I fix one, the other one kicks in, and the other way around. Main Lexer GC. Let me just try one thing. I want to see if it's this or this that causes it. Okay, so now it works. So it is this one. So we add something to our garbage collector which we shouldn't. So let's see if we can debug this a little bit better. If we add something of the sort trying to free and then the address, this will be GPN and the integer. So this makes it a little bit easier to debug. Okay, 980. And if we go to our Lexer and let's print the address of this x's prime, the result of the lexing process. So x's prime is equal to and let's see if that's the same. B00. No, it's not that one. So then it must be one of the regular x's. I think. Nine A0. It's not. So what is it? Is it the garbage collector itself? If we go to make garbage, and we print that, so let's see, 9A0. We have an A0, but it's not the 9. Well, let's keep looking. What else can it be? It could be a string, perhaps. Make string. B0, A0. Can it be a token singularis? Make token. This is probably the last resort, so to speak. Because what else can it be? Alright, so 9A0. Made token, made token, made token, made token. I don't see any 9A0. Okay, so what do we have left? Is it possible that it's one of these, but we don't call the constructor? We construct it manually. So let's go through mallocs. Here we create a token, but yeah, inside of the tcons. This could be it. But don't think so. Or maybe. Maybe it is. Let's print it tease like this. Make. I think we have found it now. 9A0 made token 820. Okay, not there, but we do the same down here. And voila, let's see. 9A0 made token, here it is. Okay, so we make a token for BR with this address. We do also make a token, a text token, with the same address. That's weird. Ah, this is a realloc. But we're adding X's to the GC. But we're not adding the T's, not right here anyway. But we must be doing it somewhere. Here we're adding the old T's. And we're adding the old. But that doesn't seem to be a problem. Red contents text token. This could be it. Line 284. Let's highlight that, but not comment it out. And what do we add here? The ret. And this is a token that we allocate. Okay. So here we basically add it in two places, don't we? Maybe we should comment this out. And there we go. It works. Pretty nice. We can remove both of these lines and the variable itself. Let's remove those messages as well. Trying to... This can go. And this and this and this. Let's save and compile. And let's also remove this creating thing inside of where creating. Create, oh, yeah, here. Okay, and let's compile and run it. Look at this. Okay, we get a weird 7 at the beginning, but HTML, body, ABC, BR, CDE, body, HTML. So maybe I just hit the wrong key. Yeah, I did. I'm glad I didn't troubleshoot that. I must have hit that key. Right? Yeah. All right. So, ladies and gentlemen, we have successfully lexed an HTML file. So, yeah, the hardest part is done. The only thing we need to do more is parsing the tokens. And that will be pretty easy with the current structure that we have. So, if you like this episode and this series, please like and subscribe. Thank you for watching, and thanks for today.